Okay, hopefully you have watched Flip a Coin by Studio C, and we're going to answer these questions. So we're going to represent the amount of money, f of x, that Matt owes Whitney after flipping the coin x times. We're going to do that in a table. So let's suppose that Matt flips coin one time. How much money does he owe Whitney? If you've watched the video, and don't be like, oh, I'm not going to watch the video. No, really, it's worth your time. What? You watch it. You get $1. You don't get $1. Matt owes Whitney $1. Okay, when Matt had flipped the coin 2 times, he owed Whitney $2. And at this point, I mean, you've seen the video, hopefully, and you'll probably say, logically, well, then 3 would be 3. It's not. If you plug in 3, and see the video, it's 4. So when Matt flipped the coin 3 times, he owed Whitney $4. And so it looks like we're doubling over here. So when he had flipped the coin 4 times, he owed her $8. And then 5 times would be 16, and you can catch the drift. So number 1 is done. We're going to write a function that represents how much money Matt owes Whitney after flipping the coin x times. What in the world does that mean? Well, let's see. All right, so my final answer on this is going to be f of x equals something. And I want to write a function that does this. Now, I recommend that you take some solid guesses. Try this on your own. Pause the video, please, 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 because the purpose of this question is to develop your thinking. So I am going to talk you through it, but I'd like for you to pause it and try it on your own first. So here goes. Here goes my talking. Hopefully you've tried. So because we are doubling, we need to, well, let's do it wrong. We need to just, well, double the input, right? Okay, so if I double the input, I'd get the output. Sounds good for 8. It doesn't work for 3, for 2, or for 1. Okay? Well, when I have, let's see, when I double the input, I get the output. No, that would be this one. So let's see what I'm doing. I'm doubling as I move down. So as repeated doubling is repeatedly multiplying by 2, and repeated multiplication is exponentiation. So this is what I have. Okay, so we'll go with that. So 2 to the x, not 2 times x, but 2 to the x. These are my guesses. We're going to scroll through till we get the right one. Maybe we'll stop here. We'll see. So 2 to the x. 2 to the 1 would be 2. Okay. 2 to the 2 would be 4. 2 to the 3 would be 8. Oh, man. Okay, so here's the deal. If the answer was 2 to the x, and it's not, if the answer was truly 2 to the x, then we would have another column out here. Don't have to write all this. And it would be, well, 2 to the 1, which would be 2, 2 to the 2, which would be 4, 2 to the 3, which would be 8, and then 2 to the 4, which would be 16. And so this is what I would have if it was truly 2 to the x, but it's not, because my actual answer is half of that. So it's not 2 to the x, it's 1/2 of 2 to the x. And the temptation would say, oh, well, then 1/2 of 2 to the x would be, well, then 1/2 of 2 would be 1. And so you're going to have 1 to the x. 1 to the x is not it at all. 1 to the x is going to give you 1, no matter what you plug in, right? This is 1/2, 2 to the x. That is the final answer, actually, because if I indeed do take half of whatever I get when I exponentiate, then I'd have 1/2 of 2, 1/2 of 4, 1/2 of 8, 1/2 of 16, and I would get these answers. So my final answer for this one is indeed 1/2 times 2 to the x. So what is a realistic domain for this function, and what is the range? Now, the realistic domain for this function, just looking at this, would be 1, 2, 3, 4. So I'm going to say positive integers. So the domain is going to be positive integers. Now, there are those who would say, oh, well, the domain is going to be all real numbers, because in a minute you're going to see the graph and you're going to say, oh, all real numbers, because we're used to looking at it in that context. Not necessarily. So what is the range? Okay. Let's see, 1, 2, 4, 8, 16, 32, 64. Sounds like powers of 2 to me. So I'm going to say powers of 2, and the exponent of 2 is going to be an integer. So powers of 2, I think that is sufficient right there. All right, so how many times was the coin flipped when Matt owes Whitney $536,000,000 $870,912. We're going to try to answer this without rewatching the video, and we're going to use math. So I am going to grab a calculator here, and when I do, that's going to help me sort of work through a process, and you're going to see where we're going with this. There's more than one way to do this one, and we're going to learn a method in the next lesson that'll help us solve an equation like this. So what I'm really asking is, and here's this same scrap piece of paper, what I'm really asking is, if I had 536,870,912 and it equaled 1/2 times 2 to the x, what would x be? And so I could experiment with x values and try to get this. I could also, and I'm just giving you some strategies here, so hopefully you've paused the video and tried this on your own. I could also just kind of make things up as I go. All right, so let's see. 8 times 2 would be 16. So this is 5 flips of the coin times 2. That'd be 6 flips of the coin. 7, 8, 9, 10, 11, 12, 13, 14. See where this is going, right? And we're going to stop at 536,870,912, right? And we'll just keep going. And it's easy to lose count. So there are several ways of doing it, and oh, that was it right there. So how many times did I press enter? I don't know. Well, it's not how many times I pressed enter, but what number was I on as I was counting. It's easy to lose count on that. So we're going to do this the best we can, and I'm going to start solving this. First of all, 1/2 of 2, not a thing. We're going to divide by 1/2, which is kind of sloppy. I could double instead, but I didn't feel like it. So when I do that, I'm going to have 1,073,741,824, and that's equal to 2 to the x. And at this point, I can just start guessing, and that is a logical and reasonable way of doing this mathematically. Even though that number is staring me in the face right now, I don't know what that exponent would be. So let's just guess. 2 to what? 10? Nah. 2 to what? 14? No. 2 to the 20? No. 2 to what? Okay, and I'm going to let you figure this one out. I'm not going to finish this one. I'll let you figure out exactly what it is. All right. Leave you hanging, isn't it? All right, sketch a graph of a few points of this function. So we're going to do that. And in keeping with some previous lessons, I'm going to let the original be blue and the inverse be red, because we're going to have to graph the inverse in a moment. So 1, 1, 2, 2, 3, not 3, 3, 4, 4, 8, and then it goes up to 16. Whoops, whoops, whoops. That's not where 8 is. Silly goose. I'm not a goose. There we go. Crisis averted. 4, 8, 1, 2, 3, 4, 5, 6, 7, 8. And there we go. There's the original function. And if you connect the dots, which is something we logically do, or we naturally do, we'd be like, oh, I'm going to connect my dots. And we could connect them over here, and when we do, we would hover above but never touch the x-axis. We'd get closer and closer but never actually touch it. And I want to point out the fact that we should not connect these dots, because this function has a domain of positive integers. Because nowhere in the video did Matt flip the coin 1.5 times. That's not even logical, okay? So you're going to have points, not connected points. Now, done. We've done that one. On the same coordinate plane, sketch the inverse. Okay, easy. So the original function is in blue, the inverse is going to be in red, and all I want to do is just swap my coordinates. So 1, 1, 2, 2, 4, 3, 8, 4. Okay. 1, 1, 2, 2, 4, 1, 2, 3, 4, 3, 1, 2, 3, 4. Oh. Get the white out. He did it again. There it is. All right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. There we go. I don't recommend you connect them. And then it says, what does the inverse represent? Okay, the inverse is going to basically be the opposite of this sentence. The number of flips determines how much money Matt owes Whitney. So now when I'm dealing with the inverse, when I am given how much money Whitney is owed, I'll be able to determine how many times Matt flipped the coin. That's what the inverse would be. Now, we're not asked to find the inverse. That would involve some things that are in the next lesson. But I do want to go ahead and just start articulating what this would be. So let's write that out. The original function, which I'm not going to write out, is when given the number of flips, we can determine how much money is owed. So the inverse is when given the amount of money owed, we get an output that is, or that corresponds to, the number of coin flips.